Hey, I want to quickly demo cosmic ray simulation on a Yorktown-like quantum chip in QrackOpenRelativity. But this is the editor setup. For the substrate, we're modeling silicon. These are basically material properties of silicon, and this is with no shielding. This is at the intensity of cosmic rays at the edge of Earth's atmosphere. And it's a little laggy, but if we... Okay, so you can see those qubit local reduced density matrix indicators are kind of bouncing up and down and left and right. It's not really a coherent, smooth motion. That's because of the cosmic ray impacts on the unshielded substrate. But if we change the shielding factor to 2, which is the equivalent of blocking 3/4 of cosmic rays incident upon the substrate, then when we come back in here, you can see it's, I mean, it might be difficult to tell. You might have to look at it several times, but it's a little more coherent at this point. Maybe we can turn it up to 4 just to be sure. But the gate movements are actually smooth. They're actually simulated as occurring in a finite time continuously. So it's relatively easy to tell the difference between this with very few cosmic ray impacts. You can see that the states are mostly moving smoothly and coherently, once again, versus a shielding factor of 0 or unshielded at the top of the atmosphere. And once again, when this calms down, I mean, it's probabilistic, but these indicators are moving erratically and discontinuously. The cosmic ray interaction is a discontinuous action in this case. If the energy of the cosmic ray impact shockwave is larger or as large as the energy level separation between silicon 0 and 1 state, silicon qubit 0 and 1 states, and I looked this up for an example. Obviously it's going to differ quantum computer to quantum computer, but if the energy from the cosmic ray when it passes the qubit position on the substrate is greater than or equal to the energy difference between 0 and 1 states, then it drives X and Z bit flips, which happen discontinuously. But thank you for checking this out. You'll hear more about it soon, I'm sure.